Hey guys, today we are starting Unit 4 and we're going to be evaluating sinusoids or sinusoidal functions. So today, obviously, we're going to be using our calculator. I'll get out of this, it looks terrible. And we're going to ask, how do I evaluate a sinusoidal function algebraically and using a calculator? So, as a quick reminder, remember, when you are trying to move a sine or cosine, so for instance, maybe you have sine of x equals to 8 or something like that. Not going to work. But when I look at this, in order to figure out and move the sine to the other side, remember I can't just divide by sine. That's not a valid operation. What I need to do is take the inverse trig function of both sides. So in this case, it's sine. And then those two things will cancel. So this is kind of like squaring a square root. This now goes away. You're just left with whatever was in your argument, and then over there, the thing that you're trying to solve for. So let's look at some of our sinusoidal equations. Okay, so this is number 1. F of x equals 2 plus 3 cosine pi over 9 times the quantity x minus 6. And we've graphed this before. We named our a values, our b values, our c values, our d values, and we used all of those to mark up our x and y axes. Now, though, we want to know what are specific values on this. And if I go ahead and look at this thing, remember, f of x is the same thing as saying y. Okay, and so if I have a number in here, that means they gave me an x value. So I'm going to go ahead and plug in wherever I see an x in my equation with an 8. Okay, and you know 8 minus 6. 8 minus 6 is just 2. Now, even if we had to, though, we can't take the cosine of 2 pi over 9. Because one of the big things here is, remember, this cosine, we're finding the cosine of that entire argument. And we only know those special values, the special values on your unit circle. So we're going to have to use our calculator on this point. So if you go into your calculator, the first thing you need to do is make sure that you are in radians, and I'm not in radians. So I'm going to go down, hit radians, enter, and then quit. Now I'm just going to type this in exactly like it looks. So I'm going to do 2 plus 3 times the cosine. Now please, please, please be careful here. Your parentheses, you're going to put your pi over 9. Now you can put these with a divide sign, or the new operating system on the yellow calculators has this cool thing where if you hit alpha, then y equals, you get a fraction screen come up, and now I can type it exactly as a fraction. So I'd type pi over 9, and then in parentheses, I'd either type in 2 or I could just type in 8 minus 6 if I was too lazy to do that. So if you notice, there's 2 parentheses in here, so I need to close it one more time, and this is going to give me my answer. Okay, and so notice if I type this in, if I had a black calculator, or I just didn't feel like finding my fraction screen, this is how I could type this in. So you notice there's a lot of parentheses going on in there. Make sure you don't close them too soon, and you're going to get the same thing either way. So your answer would be this business right here. However, we're going to round to 3 decimal places. That is where AP likes us to round to. So I'm going to go 4.298 would be my answer for this guy. So this one's just plugging in x. Okay, this next one, remember f of x is y, so they've given me a y value. They want me to figure out where my function is equal to 1.3. It's so big, x minus 6. Okay, and so this is basically just algebra. So what I need to do here is isolate my cosine, so I can get the x by itself eventually. And so this is just the regular algebra that you've always been doing. In order to move 2 to the other side, I'm going to subtract 2 from both sides. And just for posterity's sake, I'm not going to, oh, this isn't the fraction one, never mind. I'm just going to go ahead and figure out that that's negative 0.7. This guy cancels out. I'm left with 3 cosine pi over 9 x minus 6. Okay, now cosine still has something next to it. I'm going to go ahead, since these two are divided, multiplied, I'm going to divide. And that's going to leave me with negative 0.07 divided by 3 equals the cosine of all that stuff. Okay, I am going to leave this alone. I know I could get this as a decimal, but because we're going to be using our calculator, we want to make it as exact as possible up until that last minute. So leave that as a fraction. Okay, now, in order for me to take this cosine and move it to the other side, I'm going to go ahead and do what I reminded you in the beginning of the video and take the inverse cosine of both sides. So if I take the inverse cosine of this side, I get this thing. And if I take the inverse cosine of this side, all I'm going to get is whatever was left in the argument. And so this is the equation I'm dealing with. Now, if you look at this right here, this is something I cannot do without a calculator. That is not one of my principal inverse values. I don't know what angle would give me that crazy number. So this is something I cannot do without a calculator. So that's when I'm going to go into my calculator and find my inverse cosine of that number. Make sure you're in radians. So second cosine would get you your inverse cosine. Again, you can make a big old fraction if you want, or you can just type it in as it divides. So negative 0.7 all over 3. And then I would get that value is 1.86. Wait, 1.806. Sorry, I can't read today apparently. Okay, so that would get me that the value of that thing is 1.806. Now there's only one problem with this, and that is because your calculator only calculates your principal inverse value. So your calculator looks at this and only finds that first quadrant where it's a positive or a negative value. So in this case, it found the first quadrant where cosine was negative. And so if you looked at your unit circle, remember we have all students take calculus. So what your calculator found, your calculator for 1.806 found this value. That was your calculator, because remember, cosine is negative in quadrant 2. Because its restricted range is 0 to pi. So that's what your calculator found. If I'm looking for a general solution though, I have to find all the places where cosine is negative on my coordinate plane. So your calculator found 1.86, which makes sense because if this is pi radians, that's about 3.14, about halfway in between that would be 1.57 radians, and so that makes sense. Now the only thing is we're looking for the other place where cosine is negative. So cosine is negative, is positive up here, negative over here, negative here, positive here. So this is the value I'm looking for. I need to figure out what that angle is. So I have this angle, and now I need to figure out what that other angle is. And the easiest way that I can do that, to find the equivalent reference angle, I'm going to write that equivalent reference angle in quadrant 3 is to just make whatever you have negative. So if you found that that was a positive 1.806 radians, this is negative 1.806 radians, because all I've done is gone the other direction and it would put me in the same spot. So those are the two angles that would get me that initial positive or negative value, because I'm looking for a negative cosine in here. So what I'm going to do first is I'm going to write with my principal value. The first value that I had was, I'm going to go ahead and draw a little line or something. I have the one that was in quadrant 2, and it was 1.806. Remember, to find a general solution, you're going to go ahead and say, well, I could just keep adding coterminal angles. So 2 pi times n, and that would equal whatever was over here. So pi over 9 times x minus 6. Now this is just an equation that you need to go ahead and try to solve for x. And so in order to do that, I'm going to go ahead and on both sides, I'm going to multiply by 9 over pi. Okay, and the reciprocal of that guy, because that'll cancel out all that business. And then I can distribute. Using my calculator, I'd find out that this is 5.174. If I distribute this 9 over pi to the 2 pi n, the pi's go away. So I'm just left with 9 times 2, which is 18. That's how I find the next interval, and that would give me x minus 6, whatever was left in my parentheses. Using algebra, just add 6 to both sides, remembering that 18n, you can't add the 6 to that, so I'm going to add it to my 5.174, and that gets me, my first general solution is this business. So that's your first general solution. Now my only issue here is that's only my first one. I've got to go ahead and find the second one. And that second one is the one that was in quadrant 3. Okay, this guy. And remember, I said that it was easiest to just take the negative of what you found for the other reference angle. So for this guy, this would just be negative 1.806 plus 2 pi n. Again, it's the same going around your circle, equals to pi over 9, x minus 6. And then you do the same thing. You solve this guy out for x. And so again, I'd multiply by the reciprocal. 9 over pi. I would get, my distribution would give me negative 5.174 plus 18n. Again, it shouldn't change. That second part shouldn't change. Then x minus 6. Add 6 to both sides. And again, use your calculator on this. Make sure that you're not messing up easy stuff in here. And you'd find that your other general solution would be 0.826 plus 18n equals x. So the two answers that they were looking for here are this guy and this guy. So these two are my general solution. Just remember, we always have two answers in here. So those are the two different values for x that you could have. So if they asked you for the first 3 positive values, it's pretty similar to the way we did before. So my first positive value would be this guy, the 0.826. My next positive value would be the other guy, right? Because this is that first one. Then we would go to the second one. So 11.174. And then I would just take it and add my smallest with its interval. So 0.826 plus 18. My next angle would be 18.826. Okay, and so again, you have two equations for your general solutions, and if they asked you for positive values, then you're just going to go in and plug in. If one was negative, just plug in another value until you get the first 3 positive answers. Okay, and so again, this is all just algebra. So let's go ahead and try one more. Go ahead and write this down. F of x equals 4 plus 3 sine of pi over 6 x minus 2. And they want to know, where is f of x equal to 6? So we're going to go through the same steps here. Wherever I had my y value or my f of x, I'm just going to go ahead and plug in a 6. And now I need to get my trig function alone. So in this case, it's a sine function. So I'm going to subtract 4 from both sides. That gets me to equals to positive 3 sine of pi over 6 x minus 2. Then I'm going to divide both sides by the number in front of the trig function. So I get 2/3 equals to that entire trig function. And now I'm going to take the inverse of both sides, so that way I can figure out what that number is and get the sign by itself. So I'm going to have the inverse sine of that value equals pi over 6 all over x minus 2. So that's pretty much the more straightforward part. That is the algebra part that shouldn't be too bad. So if I go ahead and figure out in my calculator what the inverse sine of 2/3 is, I would get that lovely number. Okay, and so remember, I'm going to round to 3 decimals. And so my first thing that I'm going to do, I'm going to go ahead and split it into 2. And I'm going to have 0.7297 rounds up to 0.730 plus 2 pi n. Again, you're always just going to do 2 pi n equals, well, it helps if I write equals, not plus, pi over 6 times x minus 2. Okay, and so again, this is just doing some algebra in here. You would go ahead and times both sides by 6 over pi. Distribute out. That would get me 1.394. Again, check in your calculator if you don't believe me. And then you're going to go ahead, if you times this together, you would get 12n, left with just x minus 2. Then we're going to go ahead and add 2 to both sides, again checking for like terms, and then you get 3.394 plus 12n equals x. So that's the first part of my general solution. So if I think back into my unit circle, all students take calculus. Since I found a positive value here, the 0.73, my calculator had calculated this guy for me. This was my calculator one. And now what I need is I need the other place where sine is positive. And sine is positive over here in quadrant 2. Okay, so my calculator found me that this was 0.73. And if you remember how I labeled this before, this guy would be 3.14. And remember, I am trying to find this angle, not just the reference angle. I want to find the whole thing in order to get over there. And there's a couple ways to do this, but the easiest way to do this guy is to take this angle that you got and take the whole way around and subtract them. So in order to figure out the orange one that I did over there, we're going to take pi, or 3.14, minus 0.730, and that's going to get me that reference angle. So if I go ahead and I do pi minus that other angle, and you can always do second answer. Apparently I feel like making this harder than it has to be, and I'm going to find out that other one, the one in quadrant 2, is going to be 2.412 plus 2 pi n equals pi over 6 times x minus 2. Then I just do all that same algebra stuff that we did before, and we take this, times it by 6 over pi. Then you would get 4.607 plus, you notice the intervals should stay the same, so 12n equals to x minus 2. Add 2 to both sides. That gets me 6.607 plus 12n equals to x. So these two things are my general solution. Okay, so that was how we would solve these algebraically. You can do this in your calculator, and I will show you that tomorrow in class. If you want to kind of think about it right now, we would be finding the intersection of these two lines, and yes, there's a shortcut in your calculator. Have a great night, guys.